let's start talking about myself a bit. So, my name is Jun Furuse, and I have two ways of involvement with Tezos. The one is as a scientific director of Tezos Japan Foundation. I think this is the right logo of ours, right? Yeah. Okay. So another role is I am a CEO of a small company called Lambda, well founded by myself. And through this company, I work for Tezos core development. And actually, I am based in Kyoto. Okay, so I guess many of you already know what is Tezos, but I see several guys who are not familiar with. So let's quickly go through about what is Tezos. Oh, and by the way, forgive my poor English. Some coughs I will make. Okay, so Tezos is quite in short, it's a next generation blockchain technology. And we have these kind of sales points. One is dedicated proof of stake and on-chain governance, and it's designed for family formal verification friendly framework to have more security. And the mainnet of Tezos has launched on last September. And currently, we have small glitches on to currently it works. So let's go through these sales points. So first is liquid proof of stake. So Tezos is not a POW, proof of work blockchain, but proof of stake blockchain, but with delegation. And it is often called, some people uses the word deepos often for proof of stake with delegation. But ours, Tezos proof of stake is a bit different from what is so-called deepos. So let's see what are different. So in LPOS, unlike deepos, everyone can become a validator of the blockchain. Well, there is a small condition that you have to own some amount of tokens, but if you have cleared this condition, you can start validating or mining. And in Tezos, we call it baking. Okay. And if you are not familiar with the technology, or you are not so, if you're not so familiar with technologies, you can delegate your baking right to those baking services, and you can get some rewards from those services. And since it's POS, so it's quite light to mine. So you don't need any kind of special hardware. So even if a small tiny Raspberry Pi 3, you can make your own blocks. And for on-chain governance, so another special point of Tezos that stakeholders, token holders, can change the protocol. And the way how to change the protocol, the procedure is already coded inside the protocol. So in our Tezos on-chain governance, so you can first propose the protocol amendment, then we do some voting and testing, and finally we decide whether we really use it for the upgrade or not. And if the final voting passes, this upgrade is automatically integrated to the new protocol. And I'm going to talk. I will talk this on-chain governance later. This is just an overview. Okay. And the Tezos is also well known to be friendly with formal verification. So this is formal verification is a way to mathematically logically prove that your programs never doing something wrong. So it's completely different from software testing. So in software testing, what you can do is at most try and run your system with some very finite, limited number of test cases. So there is no guarantee that any untested case, if your system C, there is no guarantee that your system can really work properly with those untested cases. So with formal verification, we can prove mathematical properties that your program work correctly for any case. So it gives you much more firm confidence of your safety of your software system. So to do this, Tezos is firstly written in OCaml, functional programming language, which is really a good match with formal verification. So OCaml has grown up around formal verification studies for years, maybe nearly 20 years. Okay, so in Tezos we use those technologies called static typing or model checking, proof assistance, and so on, to provide safety proofs of every aspect of our system. For example, protocol layers or P2P layers and the smart contracts and so on. So I'm not going to cover all of this, but many people all over the world are trying to prove or secure as a system using those formal verification techniques. Okay, so that's the quick overview of Tezos system. So today I'm going to talk about the recent development in the Tezos core team. And several of them are so new, so I tried to explain you, but probably it's too new, so even I don't understand fully. So, well, anyway, let's go. So we have, since the mainnet launch, we had several issues and we patched our systems, but apart from that, we worked hard on providing new things to Tezos. Okay, those kinds. So it's not a development, but one of the big news is that about nomadic clouds. So nomadic clouds is a central Tezos core development. So it's a company of 30 or 40 engineers, and they based in Paris, and they work for Tezos core development. So they are the main team of Tezos development, and until recently they have never exposed themselves. Well, this never means that they are a kind of secret society or anything, but they really didn't need to advertise themselves. But just recently, just after, probably I guess they are pretty busy to release the mainnet. After that, they started gradually expose themselves. So I think their homepage, webpage are out in last November, I guess. And they have started writing brilliant blog articles about Tezos and around technologies. So please check what they wrote and what they are going to write. Okay. And another big news is that our first protocol amendment is coming pretty soon. So currently what we are discussing that there are two candidates of protocol upgrades. One is increase in gas limit, and the other is plus increase gas limit plus reducing load size requirement. So what's they? So the first one is increase gas limit. Currently, Tezos smart contracts has some limit to run in a Tezos node so that you cannot infinitely run your contract. So this is called gas limit, and this gas limit in the current protocol is really limited to some very conservative value, so that never to make sure that any kind of bad smart contracts never crashes our Tezos node. But this, of course, limits the ability of smart contracts. So there are several requests from smart contract developers that this gas limit is too small, so they have to be increased. So we are going to relax, I don't know how much, but they are going to relax the limit of the smart contract gas. Yeah, in the next proposal. And another proposal contains reduce the roll size requirement. So currently, if you want to bake or you want to vote, you have to own 10,000 Tezos. It's called roll. So if you don't own, if you own less than one roll, you have no right to vote or bake. So this proposal is to reduce this roll size from 10,000 to 8,000. So this means that we will have more rolls available in our full Tezos network, which means that we have more bakers, or if you have only currently if you only own 9,000 Tezos, you cannot bake yourself. But after this, if this proposal passes, you can start baking by yourself. And this also connects to the voting right. So this in the end, this makes gives more right of baking, right of voting to more people, which makes more decentralization in the network, which is considered generally very good for blockchain technology. Okay. And those proposals are not yet formally registered. This is those. So if in Tezos, if you want to propose some new upgrade, you have to describe what you want to upgrade in OCaml code, and you have to use some RPC, Tezos RPC, to register your proposal on the blockchain. But it's not yet done. So currently, what we are doing, so our core team is currently really busy to finishing those tests of voting system itself. And in parallel, we have started community proposal discussions in this, I don't know what it is, but it's kind of a discussion framework. Okay. And once this proposal is registered in the blockchain, then the whole process start including this proposal after selection of votes, which idea we are going to test, and testing the selected proposal and the final vote to upgrade or not will take about 3 months. So there's some amount of time. So if you own some theses and if you have some voting right, please learn how the voting procedure works and think a bit about the proposal and decide you vote or not. Okay. And another big news, actually it's released yesterday, is a storage improvement. So if you run your own Tezos node, you immediately storage space used by a Tezos node is so huge that actually it exceeds 68 gigabytes in the middle of January. I remember in November or October it was around 40 gigs. So it's increasing, and it's just it makes it really hard to run a node by yourself. So Tezos core team worked really hard to fix this problem as soon as possible, and a fix was proposed just yesterday. Well, I'm sorry, the fix is there, but they have released some detailed explanation yesterday. So the idea is to provide some pruning, which means that removes some unnecessary data to run the node correctly. And in addition, they also introduced garbage collection. So to do this, this 68 gigabytes disk space went down to 14 gigs. And since this pruning and garbage collections discards really old data which are not required to running blockchain. So it also reduces, it also prevents the disk usage from increasing from this 14 gigs. So it's really good news. And if you currently, if you want to start your Tezos node from scratch, from Genesis block, it requires several days to synchronize to the current state of the blockchain. But thanks to this improvement, now it takes only a few minutes using a snapshot released regularly by Tezos community. So all of this is explained in this web page of Nomatic. And this is not a really technological advancement, but we have created, or we have asked Stack Exchange to create a new Tezos Q&A site, and now it's in beta. And here already you can see a lot of interesting questions. Well, mainly really technical questions. So, and you can see several answers there. And we encourage you to join and ask your questions. And even core developers these days, core developers, if they ask some questions internally, in our internal chat, they're immediately scolded. Not to ask this question here, but to ask here, to make them so that we can share the same knowledge, even outside of the core developers. Okay. So that's the main released updates. So now I want to cover other ongoing updates or development efforts. So first one is even better storage. So we have already solved the most immediate, most important, and most serious problem of storage size increase using pooling and garbage collection. But in parallel, there are several teams working on provide even better storage space and speed, access efficiency. So these projects are called Play Layer, Bringing to Iron Test. But I'm not really sure about the details. There are some efforts to make storage even better. And BFD-like consensus, yes. So we also, it's mainly by Arthur Drakeman himself, but or we are working to provide BFT, Byzantine fault tolerance alloys over Tezos. But it doesn't mean that we are not going to. It doesn't mean we are going to change the current design drastically. It's just we can just introduce BFT. So I mean the basic design of baking plus endorsement never change. So what we are currently considering is to introduce this BFT for endorsement to make sure that all the many papers can agree on that information. And this is QSS. Yeah. So currently, random numbers. So in Tezos, random numbers are used to choose bakers to bake a block and endorsers to endorse graded blocks. So they are chosen randomly using random seed. And this random seed is currently computed from commitments. Commitments, what are commitments? So they are secret numbers chosen by bakers. So they are personally encrypted. And later, these commitments are exposed. We call it revealed later by these bakers. And this revealing of commitments is important. Otherwise, if bakers don't do it, there's a penalty. So if the baker who forgot or ignored revealing their commitment lose rewards on the fees of the related block. So, but there's some incentive of bakers who bakers can intentionally not reveal commitments on purpose to control the random seed. Since if a baker doesn't reveal the commitment, the next random seed is computed without this commitment. So therefore, so the baker can choose two ways, to reveal the commitment or not. And if somehow a baker can detect that without revealing the commitment, he can control the random seed and to have much more baking chances other than revealing commitment. And if this expected income exceeds the penalty, then they have some incentive. They have the incentive not to do so. So to prevent this problem, we are thinking to introduce this PVSS called publicly verifiable shared secrets. I don't go into the details, but so this is to separate these commitments, secret commitments, into pieces and distribute other bakers. And so that if the baker doesn't reveal the commitment at some point, we can use this PVSS technology to recreate and reconstruct the commitment from those distributed secrets. Thus, we can make sure that commitments are revealed at the end of the cycle problem. And the case notes. I am really bad at those kind of technologies, but recently, OCaml wrapper for ZK Snaps library was committed into Tezos source code repository. And ZK Snaps is to say short, it's to bring some privacies, such as private transactions just as using Zcash. But in Tezos, we can't really use this Zcash snaps or Zcash sapling libraries immediately, since we have to coordinate our current, we have to coordinate our existing systems of baking and other things with this library. So we are currently thinking probably applying this privacy library to voting system to make the voting anonymous. So currently, if you vote something, you can, anyone can observe what you voted for from the blockchain. So this is a good thing to make things more anonymous. Okay, so the last thing I'm going to explain is a high-level language for smart contracts. So current choice is a bit limited. So one is Michelson, the virtual machine itself, virtual machine code itself. But so you can, so in Tezos, there are several tutorials, documents exist to promote you write this virtual machine codes by yourself by hand. But actually, yeah, it's good since it's a lowest language to run your smart contracts. So it's really detailed. So for example, you can calculate the gas cost and so on precisely. But it's really hard to write for human beings. So another choice is liquidity. It's a Occam-like syntax made by Occam Pro. And it works fine, but the problem is that Occam syntax is not really popular in the normal industrial blockchain smart contract. So we are currently planning to build intermediate level language over Michelson, which compiles to Michelson, and with some syntax wrappers for popular languages such as Python, JavaScript, Java, and so on. So that blockchain engineers who are familiar with those programming languages can write Tezos smart contracts more easier. And using some compiler from intermediate level language they can use this compiler to compile their smart contract to Michelson. Okay. So that's about it, and that's all from that's so far all the things I have observed from the Tezos core team recently. But not only from the core team, but there are more coming from the community. So one is wiki by TQ. TQ is called Tocqueville Group. They are actually companies around New York City working on Tezos technology. They have released Tezos Wiki, so this should be a good source of information on Tezos. And a company called Camcase started writing Michelson tutorial, which seems to be really good. And Obsidian Systems have recently released Ledger support, and this is now included as an official Ledger manager. So you can install Tezos Wallet using their Ledger GUI. And we are going to have a big Tezos summit in September this year in New York. So I hope this year too we will have a really busy 1 year in